Okay, so for the Trigo revision, I will be using a push to start worksheet to run through key concepts that you will need to know to summarize your whole understanding of Trigo. So this chapter starts with the usage of special angles. So what are special angles? They are angles which are 30 degree, 45 degree and 60 degrees. Or if you use a radian measure, they can be also be seen as pi over 3 because pi is 180 degrees. 45 is pi over 4 and 30 degrees is pi over 6. Okay, so once all these special angles here can actually be obtained using your calculator. Just key this value into your calculator, you should be able to get the form. And to obtain these exact forms over here, you can actually just square the answer and then you square it back manually yourself in order to get these special angles. All these special angles should be memorized whenever you solve trigo questions to help you. And example 1 is very straightforward. Once you know the special angles, applying it into these trigo functions is very straightforward directly. Okay, moving on to the next part. This is a very common kind of question. Given that, let's say I have a obtuse or acute angle, so once you know that theta is acute or obtuse, you first identify the quadrant first. Then after that, make use of what is given in the question. Let's say sine theta equals 3 over 5. And in this question, cos second quadrant, we go by ASTC. Second quadrant, only sign is positive. So therefore, sine theta is 3 over 5. I can draw this diagram here. Okay. And then, so therefore, I know that based on this angle here, this is my reference angle. Therefore, this is 3, this is 5. By Pythagoras theorem, I can get here to be 4. And then I can easily obtain what is cosine theta and tangent theta, bearing in mind that this is the second quadrant, so only sine is positive. Both cosine theta and tangent theta must be negative. Okay, so once you are able to grasp this concept by firstly drawing this diagram is very important in order to help you get all the trigo ratios that you need for sine theta, cosine theta, and tangent theta. Okay, once they are established that, then the rest of the question should be relatively simple. Okay, yes. So moving on to the next part, sketching trigo functions. Trigo graphs are very important for you to know how to sketch them, and there are about four main points to know how to sketch a trigo graph: shape, period, amplitude, axis of graph. So always remember, for any trigo function, there is always a general form. Let's say for sine curves, it is this general form: y equals to a sine bx plus c, whereby a, b, c can be any number or integer. Doesn't need to be integer, but it can be any number, and you need to know how to make use of these values here to obtain things like amplitude, period, etc., minimum and maximum value. Okay, so let's look into curve sketching. Let's say for example 5, I'm given this question here: how to sketch this graph. Okay, my first step is identify the shape here. This is a cosine graph, so I know that cosine graph looks like this. Okay, and this is a positive, that means that I'm going to reflect this. Okay, if it is a negative 1 minus 3 cosine 2x, then I have to flip it, and this will look like this instead. Okay, so same thing, recall for sine. Let's say if I have 3 sine x, for example, the graph looks like this. Okay, basic sine shape. But if I have a negative 3 sine x, okay, remember, always have a negative, the graph will reflect across the x-axis, and this will be how it looks like. And no matter what number is added to this, the graph shape will still stay the same. It's just how much is shifted vertically upwards or downwards. Okay, so once I can identify the shape, the next part is I can get the period. Over here, my b is 2, so the period of this, because I know that this question is in radian measure, it will be 2 pi over 2. I'll get period to be pi. And since for this question, they say that sketch the graph for x between 0 to pi. So, and I know that the period is pi, so therefore I only need to draw one cycle. One of this is called one cycle. Okay, next part, amplitude. How do I find amplitude? Amplitude is this value here multiplied to the Trigo function, and over here I know that amplitude is 3. Okay, next part, maximum and minimum value. You can just add the amplitude to this value here, negative 1, and the negative of the amplitude to add to this negative 1 in order to obtain the maximum here and the minimum here. Okay, and the axis, which is the middle line of where the curve will lie, is this value here, y equals to -1. So once I've obtained these important features of the graph, I can sketch the graph already. So how to sketch the graph? First, draw out the imaginary dotted line for the axis, the maximum point, and the minimum point, the minimum y value. Okay, once I've done that, then I will split this graph into 4 parts. So let's say I split this into 4 parts. I have one part here, 2 part here, 3 part here, and 4 part here. Okay, 4 part here, this will be the period. Okay, the period I'll leave it here. So over here no period is pi, so therefore I put a pi here. Then half the period will be pi over 2. And then this graph can be split in this 4 quadrant. And then since I know that the shape of the graph looks like this, I'll split this evenly, nicely across the 4 quadrants. So this graph will start from here, going down to this part, going down to the minimum point here, going upwards, and then going back to its to complete one cycle. So once I've done the sketching of the graph, then I must remember to label the graph as such in order to score the full marks. Okay. Then the second part, let's say I'm required to draw a line. To draw a line, we always draw a very simple table of values with 3 points that lie within this range from 0 all the way to pi. So what I chose is that I chose 0, pi as the end, and I chose the middle part, which is pi over 2, to know what are the points that lie within this line. Okay. Then the last part, when I want to state number of equation, given this here first, I must first manipulate this in order to get this equation here and this equation very clearly. So you can see what I did is that I divide both sides by 30 pi. Then after that, I add 1 to both sides, and I'll get this equation, which is the equation of the trigo curve that we drew, and this is the equation of the straight line. Only from here, then I can conclude that there are 2 solutions based on 2 intersection points between the line and the curve. Okay, moving on, solving trigo equations. This is a very common exam question also. When you want to solve trigo equation, always remember I must always find the reference angle and identify the quadrant before solving the question. So for example, let's take a very simple example. Let's say I have maybe let's look at part C, for example. Okay, I'm given this original equation. So when I solve trigo equations, one common trick to do is that we always want to change all of them to have the same function. And we want to solve this equation to solve for y is cosine x, for example, in this case. So what I did is that I turned this sine square x based on my trigo identity into this trigo identity here. Then I can easily manipulate this equation to get a quadratic equation in cosine x that I factorize out in order to find cosine x eventually. So you can do whatever way you want. You must just need to make sure that you manipulate the equation. And if I have factors, then I can, let's say I have a certain factor times a factor equals to 0. Then from there I can equate that either one of the factors will be equals to 0 to solve trigo equations. So how to solve trigo equations? Once I reach this step here, okay, make your in this case here cosine x the subject equals to, let's say, 1/3 or -3/4. Then next step, identify the quadrant based on your ASTC. So always remember your ASTC, very important. Okay, so over here cosine is positive, so I know that positive for cosine ratio is only in the first and fourth quadrant. When cosine is negative, it's only in the second and third quadrant. Once I've identified the quadrant, then I must find a reference angle by taking, let's say in this case here, cosine inverse 1/3. And over here, this is a very important point. Even though this is negative, reference angle is always positive. So I only consider cosine inverse 3/4, not -3/4. Okay, then from here I can get the reference angle for both. Then I can easily solve the question. Therefore, x is equal to, based on the quadrant, first quadrant is just the reference angle. Fourth quadrant, it is the 2 pi minus the reference angle to get the final answer. And for second and third quadrant, second quadrant will be pi plus reference angle and pi minus away reference angle. Okay, this is your this is the third quadrant, this is the second quadrant. Yeah, so this is a very general summary and recap of how to solve basic trigo equations. Okay. And R formula is something that this is really, you need to just memorize how to use R formula. So I won't be spending a lot of time on this, because this as long as you memorize this, showing the steps very clearly, you should be able to solve R formula questions without any issue. Okay. Okay, moving on to the last part, a very, very important and a common exam question, proving Trigo identities. When you want to prove Trigo identities, always remember, I want to show, let's say I'm asked to prove this. Okay, what I want to show is that I start from one side, I work, simplify everything, I should be able to get this side over here eventually. Or you can start from the right hand side. You expand and use all your Trigo identities in order to get this thing on the left hand side. So this is the general method of how to prove Trigo identities. Or you can also start from left hand side, get to a certain point over here, then right hand side get to the same point as well. This is also okay, but it is a bit more complicated. So usually a tip is that when I see Trigo identities and I'm required to prove them, I usually try to choose the more complicated side, because when I choose a more complicated side, then I always try to simplify it. It's easier to see how to simplify much more complicated terms than starting from a very, very simple term like this in order to get this side here. Okay, so basically start from the, in this case here, all my left hand side seem more complicated. I start from the left hand side, and then you slowly work out in different ways to solve and prove the Trigo identities. And you realize that from here is that there are so many different ways to prove Trigo identities. And it may not be easy, but as long as you don't give up, you should be able to get somewhere. And even if you don't get the answer in the end, as long as we can see methods for certain parts which we are looking out for, you may score method marks as well. So always remember, even though you might think it's hard, try to work out something, try to write whatever that you can apply from your Trigo identities or the Trigo knowledge that you know, such that for such questions, even if you can't get the final answer, you would be able to get some method marks to solve these questions. Okay, yep. So like that, this is a very, very brief summary of what you need to know and the skills you need to be aware of for Trigo. You need to practice more questions in order to know how proficient you are at these skills and which areas you need to work on for Trigo. Yeah, so that will be the end for this summary for this chapter on